Let me introduce you to our third keynote speaker from University Malaysia Terengganu, Associate Professor ChM Dr. Hanis Mohd Yusoff is a professional chemist and a lecturer at the Faculty of Science and Marine Environment UMT. Her research area involves the green synthesis of nanomaterials, magnesium oxide, zinc oxide, silver nanoparticles with antibacterial properties and their application as catalysts and anode materials in a battery application. Her current involvement as a project leader in UMT Talent and Publication Enhancement Research Grant entitled Green Synthesis of Zinc Oxide Nanoparticles using Mariposa christia vespertilionis leaves extract. Its morphology effect as anode material in sodium-ion battery. Her title for today is Green Synthesis of Metal and Metal Oxide Nanoparticles using Mariposa christia vespertilionis leaf extracts. Please welcome Dr.
Okay, Assalamualaikum and a very good day. Thank you so much, the
Waalaikumsalam.
lovely MC, for the introduction. So I will just continue the session today with my presentation titled Green Synthesis of Metal Oxide Nanoparticles using Mariposa christia vespertilionis leaves extract. So I am Hanis Mohd Yusoff from Faculty of Science and Marine Environment, University Malaysia Terengganu. So without further ado, I proceed to the outline of my talk today. Will be a little bit about my background since I am new to this committee, and then a short introduction, and I will discuss the silver nanoparticles, magnesium oxide nanoparticles, and zinc oxide nanoparticles. So if I still have time towards the end, I will briefly introduce about ANOMA for future collaboration. Of course, for me, I think this is like a preliminary. There are still so much things to improve. So I'm really looking forward for fruitful comments and suggestions. Okay, so for my background education, so I received my degree from UTM in 2003, and during final year project, I studied photodegradation of organic dye using titanium dioxide, and I continue my master in the same university, focusing on high surface area magnesium oxide, and later I proceed my PhD study in Tokyo University. So it's the similar as PhD, but in the scroll they use Doctor of Science. So my study was about protein adsorption on modified surfaces. Studied using scanning tunneling microscopy and time correlated single photon counting. And my background career, I joined UMT in 2007, basically teaching chemical sciences students, and then 2009 I furthered my PhD study, and back in 2013 to teaching and research in Faculty of Science and Marine Environment UMT. So this is one of my memory in Japan. At second year of PhD study, I'm the only female student in the research group. So this is my supervisor here. There are only 3 international students from Pakistan and Egypt. All right, so let's move on to introduction. So this is very well known that all of you, I'm sure, is aware that nanoparticles can be prepared in various shape and sizes, such as thin film, nanorods, nanotubes, nanowires, and so on. And among the common nanoparticles that are widely studied are for metals such as silver, gold, platinum, and for metal oxide nanoparticles, the most common one are magnesium oxide, zinc oxide, copper oxide, titanium dioxide, and so on. Why researchers are interested in these particles? Because its various application has a very wide application in chemical, biological, and also the physical, and we can also tune to its size and shape. So talking about synthesizing nanoparticles, there are top-down approach and bottom-up approach. But nowadays, this green synthesis has been extensively explored, yeah, and have been the interest of researchers nowadays. This is because they have a lot of benefits, and it has a high impact towards social, economical, and also environmental. Uh, the table here shows the common chemicals that is used for chemical synthesis, such as sodium citrate, sodium borohydrate, and so on. Of course, the main advantage is we can tune to define size, dimension, composition, and structure. However, this chemical synthesis is cost effective, and it may cause so it may cause health problem if we inhale it, and it might cause pollution towards air and water as well. So the alternative way is by green synthesis, okay, because it is from natural source, cheaper, and then it is faster, just a single step process, and it is eco-friendly with simple parameters that you can play around. And this diagram shows the difference of chemical synthesis and green synthesis, where the stabilizing agent or reducing agent in this chemical synthesis is replaced by plants in the green synthesis. And these are the common parts of plants that are used in previous study, but in our study we just focus on leaves. Okay, plants are known to have these phytochemical properties, which can act as reducing and stabilizing or capping agent. Okay, and from literature, these are among the chemicals or compounds that can be found in plants, such as flavonoids, phenolic, alkaloid, and you can see terpenoid here. And this is the common mechanism. We cannot elucidate the specific compound because in the extract there are mixtures of these. So it is very common in green synthesis that the mechanism is described like this, and towards the end we will obtain the metal nanoparticles or the metal oxide nanoparticles. Okay, so I'm showing you here the previous studies. Very extensive studies have been carried out toward metal nanoparticles, especially silver, gold, and platinum. So if you can see here, this is from leaves extract from this plant species, and they also reported the size range obtained, very small, but okay. So later I will share the one that from our group. So this is from fruit, flower, bark, followed by the seed. So they fully utilize the parts of the plant, and they have successfully synthesized these metal nanoparticles. Okay, so in our study, we focus on this Mariposa, christia, vespertilionis. So we make it a short form. We just say MCV. Okay, so why is called Mariposa? Because Mariposa is butterfly. So if you see the leaves here, the shape is similar to the butterfly. Okay, so it is reported as one of the least concerned plants. So normally this plant exhibit red and green, and we can see this plant is also used as a plant to decorate the garden, the porch. So in our study we use green Mariposa. So red is hard to find, green is easier, and it's easier to plant as well. And there are several studies reported about the properties. It has been used to treat certain diseases, but very few studies reported that it has been used to synthesize metal or metal oxide nanoparticles. So the MCV extract is prepared just by using deionized water only. Wash with deionized water and extract with deionized water, and then we obtain the extract. After that, we carry out the phytochemical studies. So for 3 sets, we found that in MCV there are traces of alkaloids, flavonoids, phenolic, and saponin. And using this water extract, it is comparable with the previous study by using specific solvent system. So they found phenol, flavonoid, coumarin, tannins, and glycosides. So the phenol and flavonoid parts is in collaborate. Okay, move on to the first metal nanoparticle, which is silver nanoparticles. So this is the method. We use 10 ml of the extract mixed with the silver nitrate and then incubated. So as you know, it is very common for nanomaterials to have this SPR, or surface plasmon resonant properties, where the metal vibrates, and then when light is excited, and then at certain angle it will propagate, which is parallel to the metal surface. So we can monitor the silver nanoparticles by these SPR properties. So in our study, by using this MCV, after 24 hours, a peak start to show. Then after about 6 days, the peak can be seen clearly at 432 nanometer. And we also see the stability is up to 2 months. And we have tried with rambutan peel previously, and the stability is only about 10 days only. However, due to the our characterization or our SEM instrument, the limitation, we cannot obtain a very good image. So I'm very eager to collaborate and get nicer image of our samples. So this is the best image that we can get at 15,000 times magnification, and roughly we estimated is about 20 to 200 nanometer of size range. As for the antibacterial study, we only managed to study towards S. aureus and P. aeruginosa. So these are carried out by final year project student just before the first MCO, the first pandemic, the first MCO. Then a lot of experiments are pending, so we just use what we have only. Okay, so there are 2 trials that were managed to be carried out, and then we also compared with chemical synthesized silver nanoparticles. So for the first trial, it seems comparable, even though it's a bit low. But for the second trial, the green synthesized silver nanoparticles exhibits larger inhibition to be compared with the chemical synthesized silver nanoparticles. Okay, so that's all for silver nanoparticles. I will proceed to the next metal oxide magnesium oxide nanoparticles. Okay, so this is the method. The precursor or the starting material is magnesium nitrate hydrate, and then with sodium hydroxide, and these are the procedures. And of course, firstly, we monitored using TGA. So it is still not complete because we cannot do DSC yet, even until now. And it is important for us to monitor the consistency of the method when dealing with green synthesis. So that's why we synthesize these separately and try to see the TGA whether it is similar or not. So it seems like consistent. So we assume that this water loss and then the loss of starting material and other organic residue. So we choose the temperature of calcination after 400, starting with 400, 600, and 900 degrees Celsius. And then, of course, the next characterization would be FTIR. So this is before calcination and after calcination. And the most important characteristic when you're dealing with a metal oxide is the metal oxide range here around 400 to 600, and this is due to the adsorbed water molecules. So it's quite common for magnesium oxide nanoparticles. Okay, so these are the band assignments, and followed by XRD. So it is comparable with the commercial and with no other impurities, and we have referred the JCPDS and PDF reference as well. Okay, for the SEM, Here are several images, which is before calcine at 400, 600, and 900. So you can see here it is a non-homogeneous, irregular shape. However, as the temperature increase, the shape seems to be smaller, and the lowest that we could get is about 100 nanometers. So it's within the range, even though we cannot get smaller as the previous study. Okay, so we also look at the UVV's properties, and we only managed to do at the 400 degrees Celsius calcine temperature. And the wavelength obtained is at 301 nanometer, which is falls within the range of the specific for magnesium oxide nanoparticles from previous studies. So the range is from 270
Sorry,
to
doctor,
360.
to
Yeah,
interrupt.
I
I
have how
beg your
many
pardon
minutes left?
for interrupting, but you have another 10 minutes to finish your
Okay,
sharing.
thank you. I will speed up my presentation.
Okay,
Okay,
doctor.
so move on to antibacterial study. Of course, there still a lot needs to be improved. We just managed to test on SRS and E. coli, and surprisingly, these magnesium oxide nanoparticles only show positive result at these gram-positive bacteria and no inhibition at all at E. coli. Okay, to the last one, zinc oxide nanoparticles. So this was the method used. Then, of course, the main thing is monitor with TGA. So similar pattern, only the plateau here is a bit higher from magnesium oxide. So then the temperature, calcination temperature started at 600 and also 800. So zinc oxide, the adsorbed water molecule is not as obvious as magnesium oxide. Okay, so you can see decrease here. Of course, the important characteristic of metal oxide stretching. Then this is the assignment. And then followed by SRD. So we get pure SRD and comparable with the commercial one. Okay, so for the zinc oxide nanoparticles, the size is slightly smaller, and then we can see quite a big difference as the temperature increases. So it is smaller, and then the lowest one is we can calculate it at 70 nanometers. So I want to do more with this morphology study, especially with FISEM or TEM, but we don't have the facilities here. Okay, and then we also carry out the UVV's properties, and again it falls at the range of the previous study and is comparable, which is from 300 to 400, and we obtain within this range 376 and 378 nanometer. Okay, for this we have we look at a different application, which is as anode material in lithium, sodium ion battery. Okay, so another one, not lithium, sodium ion battery. So there are still more room to improvise for sodium ion battery, and our study obtained slightly higher than the previous references. Okay, so if you can see the cycle performance here, and then we also have carried out with black tea extract. So MCV extract obtain a little bit higher capacity with to be compared with the black tea extract. And then we also further prove it by carry out galvanostatic charge discharge profiles, and then it is comparable with the cyclability study. Okay, and then to the conclusion and recommendation, of course, there are a lot more need to improve. We plan to do additional characterization such as DLS, EM, BET, DSC for dispersity, histogram, and so on, and to see at other parameters, especially the extract concentration, pH, to modify the morphology of the materials. And we also want to elucidate the exact mechanism. So maybe we should think about extract the specific compound, and also, of course, to expand the application. So these are some of the references. These are my FYP students and my master students. So girl power here. Then, of course, I would like to thank my highest gratitude to Associate Professor TS CHM, Dr. Nik Ahmad Nizam, Nik Malik, for this opportunity, and all the BioNanoSem Secretariat for your help. You are very friendly, and I love working with you guys, and of course, my team members and my students, and to UMT. So, do I still have time to introduce about ANOMA, Aisha? Or should we proceed to Q&A?
You have another 5 minutes more.
Okay. So briefly about ANOMA, established in 2017. It is an abbreviation from Advanced Nanomaterials Research Group under Faculty of Science and Marine Environment, University of Malaysia, Terengganu. Okay, so normally we do an annual seminar. So we did starting from 2018 and then 2019, followed by last year we expanded a bit to conference. So it is called MATES, combining two conferences. So this year we haven't discussed about it yet. So, but if we have, we will shout out the information later. So we have researcher. Previously, I was as a treasurer, but now we have the cycle change every 3 years. So this is the new chairperson, co-chairperson, secretary, and treasurer for ANOMA. And then I am now under the committee of conference. So these are for the industry. At an industry engagement or industry attachment, and then the other team are for CSR and website. And then for MYRA, we also have a team, and we also have another members to support. With that, that is all for my presentation today. Thank you so much for your kind attention.
Thank you, Dr. Hanis, for your wonderful sharing. Okay. Okay, Doctor. So right now we will move on to the Q&A session for 5 minutes. So, Doctor, there is question from Facebook user. Do you need me to read?
Yeah, it's okay. I can read it, Aisha.
Okay.
Okay, Mariposa is quite a rare plant. Okay, so in my case, in my surrounding, we can find this green very easily, but it's hard to find red. So that's why we proceed with green leaves Mariposa. Okay, there are studies carried out, but I think I found like 1 or 2 papers about the chemicals. Yeah, they extract by using a specific solvent system, but I'm sure that there is more room to do further study about these leaves. Yeah, it's very interesting, and I'm going to collaborate with organics group, especially for the organic part of the plants.
Sure. Okay, thank you, Doctor. Okay, another question, Doctor.
Okay. What are other metals nanoparticles that we can produce? Okay, so you guys can try calcium oxide, copper oxide, titanium dioxide. I would suggest that, because even though the metal oxide nanoparticles look simple, but there is still room of improvement to explore. Yeah, we don't need to think advanced like job with this and all that system. We just start with simple first. Okay.
Okay.
Okay, so for research focus, oh, another question, sorry, Aisha. Research focus of ANOMA. So basically, our team members are from physics and chemistry. So of course, the physics, they do this battery studies, and then us in chemistry, we have various fields: organic, inorganic, physical, and analysis. Have you tried
And
to
lots of
synthesize
questions.
silver? Yes, of course. I've presented the silver nanoparticles, the first part just now. Yeah, I did, right, Aisha?
Yes.
Yeah, so we obtain a very stable silver nanoparticles up to 2 months. Of course, we want to how to say, to monitor more. However, due to the pandemic, yeah, and now the FYP student who carry out the research have started master study with another supervisor, so I have no students to continue that research again. Okay, plant identification. We just carry out the basic one, phytochemical test. But we plan to do phenolic content and furthermore studies to further understand about the plant. But we just, for now, we have the basic phytochemical extract just by using water. We never use specific solvent system yet. Okay, you can see the recording version perhaps? We have it, right?
Yes, at YouTube
Okay.
and Facebook. Okay, thank you, Dr. Hanis, for your
All right. Thank you so
wonderful
much.
response. Okay.